what kind of like reasons would you go about larger or smaller bins?
So that's a very good question. So we can start playing with the bins. So let's do that a bit. I'm adding some bit and it's going to show up. So this is where you've seen the different bins. I'm doing the histogram several times with a bin width of 5. That's narrow, a little bit bigger, a little bit larger, and even larger. So 5 centimeters, 10 centimeters, 20 centimeters, 50 centimeters. And you can see like how different they look. This one clearly is not very informative. This one is more, and we could go maybe even lower. It would be bumpier and bumpier as you go. So this is where that's the place where the cow plot comes in. Where once you do 4 graphs, you can put them inside a grid. Once you have the cow plot thing by putting plot grid, BR1, 2, 3, 4, and then the labels, and then how many graphs you want, how many graphs you want in per line and per column. Okay, let's think about this bin question. So what's the answer to your own question? What do you think?
I mean, I was thinking along the lines of like, what is the statistical significance for the counts in your bins, and that kind of determines how certain you want to group them together. But I couldn't really think of it like a determining conclusive answer.
So, with histograms, basically, there is no real science to the size of the bins, but it's still useful to think about it because with kernels, which we come to in a minute, there is some science to the size of the bandwidth, which is the moral equivalent to the size of the histogram. So this is, by the way, is the same thing for US women. For histograms, when we use more and more bins, it's going to become closer and closer and closer to the observation. So it's going to espouse more and more the shape of the underlying distribution. But the problem is that it might become very, very bumpy. With fewer, so I might see a lot of little bins that really, when I go very, 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 very narrow, I might have lots and lots of little steps. Not all of them are really relevant. Like some of them are just by chance. There happen to be nobody who is, if suppose I take the bin of a half centimeter, it could be that, well, first of all, a half centimeter wouldn't work because the height is represented as whole number. But suppose I took a bin of 1 centimeter, there might be by some chance very, very few people who are exactly 153 centimeters. So there might be a hole in my histogram that don't represent anything real in the underlying distribution. It just represents some, chance. So the choice between the size of the bin is always a choice between how much information I want to try to convey from my underlying data versus how much noise I'm willing to tolerate. So the trade-off in the size of the bin is always between bias and variance. So if we really go too far, that doesn't represent the distribution at all. It pretends that all of the distribution is exactly 150 centimeters. That's wrong. If we go, this sounds fine. We could even be, have lower bins than 5 centimeters. But if we go all the way to 1, depending on the data set, it might be too much. We might have bumps that are not really there in the data. Yeah.
Is there any benefit to cleaning the data in R as opposed to just cleaning it in Excel, like the CSV file?
It depends what you call cleaning, I suppose.
Like removing
outliers and.
0 centimeter.
So I think a great advantage of doing this in whatever statistical software, doesn't have to be R, but as opposed to doing it in Excel, is that you will have a track record of what you have done. So once you come up with some raw data, so either you've collected it. So once you've collected it and it's in your data set, it exists. Even if it's, you can't just like dismiss it out of hand without keeping a record of it. Because someone who comes back wants to know what choices you made. So if you're doing in Excel, it's going to be gone, and nobody would be able to reproduce your analysis from the original data without trying to second guess what cleaning decisions you might have made. When you do it inside a program, you're keeping a track record of all the steps you're taking. So that's the advantage that's advantage number one. Advantage number two, you're less likely to make a mistake because anything you have done, you can reproduce, you can undo. So you're less likely to, so suppose you clean your data in Excel and by mistake you remove observation who should be there and then you overwrite your file, you're out of luck. Suppose you clean your data. Now, I know you wouldn't want to overwrite your file, but you just might. Suppose you're doing things in R and you're writing the code. The code exists, so you never lose the underlying data. So that's another reason to work with the code.
And the underlying CSV file doesn't change.
The underlying CSV file doesn't change. Once it's read, you read it, and then you don't touch it anymore. I mean, you could decide to output data again as at the very end of your process. You might, for whatever reason, want to output it again as a CSV file. So you could make a mistake and give it the same name, in which case it will overwrite. That would be an error. You don't want to do that. But if you don't do that, then it's never going to be. It's not touched. And typically, the things that you might want to output at the end of an R procedure is something quite different from the starting point, so you wouldn't even think of giving them the same name. So yes, you'd better have long answers. You're better off working in a code. So going back to the number of bins, you can see that intuitively, just from this description, you can see that the number of bins that the data will tolerate is going to depend on the number of observations that you have. If you have like 1 million of observations, going a centimeter for a bin is going to be just fine, because it's very, very, very likely that there is something highly irregular in one particular height, because if you have 1 million of observations, there are many in each of the. If you had 20 observations, trying to do an histogram with bin width of 1 centimeter will cause issues. You're going to have holes that just happen because you just happen to have no one of a particular height in your data set. That's not going to give you an accurate representation of how the underlying distribution looks like. So keep this discussion in mind because it's exactly the same intuitions that we carry over when we are looking at kernels.